So I have some questions in the chat about the submission of the workshop. You won't get a mail or something like that to confirm your submission. You should get some kind of okay if the form was submitted correctly. I also think that if you visit the form again, you will see an empty form, especially if you're on another computer or something like that and not logged into Drive maybe. If you get the confirmation that the form has been sent, everything is okay. Basically, it seems like maybe all the questions are about that. So, to continue then, the model view separation principle, a fundamental structuring of interactive software. So if we have interactive software, we should maybe think about the model view separation principle. And it says that you should divide your software into two parts. The view that encapsulates the user interface and presentation. The model that encapsulates the domain and business rules. The parts that actually fulfill the requirements. So stuff for user interface, put it in a view component or view encapsulation of some sort. What you call this is not that important, but often you call it view. And the model encapsulate the requirements, the stuff that actually make things work in the domain. And we encapsulate that into something we call a model. And there are two rules. You cannot have any dependencies from the model to the view. So you can't have any arrows from stuff in the view to stuff in the model to stuff in the view. Vice versa is, however, fine. As we saw, we have the interactive circle that was dependent on the circle. That is okay. The arrow goes from the view side to the model side. Perfectly fine, but not vice versa. And also, you should not put any business rules in the view. This is maybe a little more tricky because it is not likely that you add some dependency that you can easily spot in a diagram, but you kind of like add some calculation or something like that inside the user interface instead. So this is something to be wary about. You can't see the screen. That's because I have not shared the screen. Now you should see it. So a lot of stuff to remember, a lot of systems to fix and dabble with. So we will take a look at a more, I wouldn't say complex example, but a little bit more example, and based on code instead of just writing diagrams. We have our trustworthy dice game. It looks like it did before. The dice class, you have an attribute, the value, you have two operations, roll and get value. Dice game has two dices, creates them. When you call play, they are rolled, and there's the simple rule is executed, checking just did we get 7 as a total. And I've added two operations here to get the value for the first dice and get the value for the second dice. And out in the program class, I have just added some functionality to create a more user-friendly experience. So if we run this, you have the nice display, and you can now play multiple times instead of just one and having to rerun. So we can play just by pressing a key. And you can see the value of the dice if you won or lost, and you can also quit the program. So basically what we have done is I've just mashed in the user interface directly into the main method, and created a small utility function also to get an input character. And this is maybe not that nice, because the program class and the main method is, well, its responsibility is to start the program. It should possibly not also be responsible for creating a user interface and displaying a user interface and stuff like that. So this should then, according to the principle, rather be put in some kind of view stuff. And of course, an even worse solution would be to write the user interface here in the play operation of the dice game. You could do it, of course. You already have the dices here. You wouldn't need the get value operations at all. So it is indeed an attractive way of solving this problem. But then the dice game would be intermingled with the user interface technology. And to be more specific, it is very simple in this case, because we would become dependent on system.out, because this is what we use to output user interface stuff in this simple application, and we will also be dependent on system.in to get input. And in our next dice game, well, maybe we are supposed to do some kind of more fancy graphical user interface, and then we need to clean out the code from the dice game, and we cannot really do a reusable component for it because it displays a lot of stuff in the console suddenly, and, well, that would be bad. So, to do this, we should then start by creating some kind of view. So in Java, this is realized in a package. I will call this view, simply. And we will also add a new file here, and just so something like that. We can open it and we can start typing the console. And we take the code from the program class and we simply move it inside the console. So something like that. It won't work right now. Something like this will be in the main program. We will remove this one also, of course. So the main class, the main method, will just be responsible for creating objects that we need and then to just leave the control to the user interface. Okay, play the game, do whatever you would like to do to display this game that I have just created. And we should also move the business side of things into a package of their own. So we move the files dice and dice game, move them to the model package. And you could maybe name this package game or something like that instead, so the actual names does not need to be model and view. However, maybe it's clear. And across several projects, if you use the same kind of naming standard, developers know where to go look. Oh, I need to do something in the user interface. I can go directly to the view folder, and I know that somewhere in this part of the program I will be working. Oh. And you should also note that I'm not a Java expert, really. So maybe something like this could be have some missing parentheses. And this is something that is interesting, especially in Java, since you can have classes that are hidden inside packages, so you can encapsulate even further. And you need to mark classes that are visible to the outside of the package. So you need to state that it's a public class. And I suspect that we need to do this on this one also. Public. Yay, finally. Not that many errors, actually. We should, of course, test it, and it works exactly as before. It should. I lose a lot. So, any questions on kind of like the implementation? Everything is super clear. I think in C# it's kind of like namespaces instead of packages. So it's the same principles at least. So we created a model. We put the rules of the game, the classes that are generic, so to speak, for dice games inside this package. We use the view package to contain the user interface. We have a very simple user interface in this case, of course. just the console is used, and the program class now just does what it should do. It just contains the startup of the application by creating two different objects, a dice game object called G and a user interface object called UI. And it then lets the UI just play the game. If we take a look at the class diagram for this application, how should it look? What classes do we have? Do you remember? Well, you can always look at the implementation. So if we have implementation, we can always manually or automatically reverse engineer. So we have a dice class, at least. Dice. This is a little bit annoying. So let's use blue. Dice. Any other class? Dice game. Any other class? Console. Anything else? Main program if you're supposed to be really technical, but we're not. So we'll leave the main program out for now. So basically that is what we have. So how are these connected is the next question. Is dice game connected to any of the other classes? Something is happening on the chat. You can always take a look at the implementation. So, dice. This is the class. We don't have any attributes of any other type. We just have an integer. We don't use any other type in our application here. No arguments. No objects are created. We don't get any objects from any other kind. We don't declare any variables of any other type. The same in getValue. We have this math random that is actually used. We will leave that out for now because it's not dice game and it's not console at least. So we have no dependencies from dice to any other type in our system of these two other types, dice game and console. Moving on. Dice game. Does it have any knowledge or need to know about any other type in this system? Dice, exactly. We have attributes here with the type dice, and they are called m_d1 and m_d2. We create them, we roll them, we use them to execute the rules, and return values from them. So there is definitely some dependency here from dice game to the dice class. So, if we know that the dice game needs to know about dices, we then need to decide what kind of dependency we have. And in domain modeling, it was easy because everything was associations. When doing design, things are not that easy anymore, but they are quite easy anyway. We don't have any inheritance. so that is out of the question. Then we have two other options. We have association, and we have a more generic dependency. And if we have attributes, we have association. And in this case, we had attributes. So then we have association. And association is the straight line. And as we know that the dice game is the one that is dependent on dice, we have the navigability. So in the design, we add the direction of the dependencies on the associations. So we know that, well, in order to execute dice game, we need to implement the dice also. Dice game can't really work without the dice. The opposite is, however, true. The dice operates happily without the dice game. Which one is easier to reuse? The dice, exactly. It has no arrows going out to anything else. It means that if you take it and pick it up and put it somewhere else, nothing will follow. If you take the dice game and say, oh, I will reuse this, well, you had better take the dice also. It kind of like goes with the package. And this was the association. It's the same arrow or same thing as in the domain model, but it's more refined. We have the navigability. That is very important in the design. And we also have the role name. And this is the same as the attribute name in the implementation. So maybe not the greatest names in this example, but I think it will suffice. So navigability and role. And of course you can have associations that travel in both directions. And there is also in some tools and something like that, they are really strong on showing that, well, the dice is actually not really dependent on the dice game. So they put a little cross even on the roll. You can find that in some diagrams and in some tools. However, he does not use it in the book. So often it's understood, the straight arrow with the navigability in one end is understood as not being in both directions, just in one direction, without the little cross. So, all right, I think that was it for the dice game. I cannot find anything else actually in the implementation here. It's just these two dice objects that are used over and over. So that is good. Let's move on to the console. Can you spot any dependencies from this class to something else? Yeah. And where can we find that one? We can find it here in play game. And it's an argument to the play game operation. We don't have any attributes in the class of this type, so it's not an association, but it's a plain old dependency. And this object is, well, it's used here. You call play, and you get the values and stuff like that. So this is what we have from the console. And this is the dependency arrow. So basically this is what our application looks like. We have the dice, we have the dice game, and we have the console that is dependent on the dice game only. So interestingly enough, the console does not know anything about dices. And that's a good effect, I think, of encapsulation. I think maybe we should be able to so, to show that these are also parts of different packages, we have a notation for that one also. And it's actually just a folder. And we type the name of the folder in the little tab. And we put the classes that are inside the view inside the view package. And vice versa. The model package. And we can also see here that, well, this arrow flows from the view to the model. And that is okay. Had it been vice versa, it would not have been okay. So I get a comment here on the chat about the model view and controller. And that is a common pattern also in interactive applications. And actually you can view the model view controller as a refinement of the model view separation principle. So tomorrow we will talk more about model view and controller. But in this case we will kind of like have both controller and view behavior inside the view. And this is what you need to stick to in the workshop also. You can use model view controller if you want to, because it's just another way to achieve model view separation. But if you don't want to do that, you can stick to just having model and view. Sometimes, just to make things clearer, I call this package UI instead, because often it's confusion about what we mean by saying view. Some interpret it as the view in a model view controller architecture, and some as a more as the model view separation principle. So, I think we have actually time for some mistakes you maybe could do. The second mistake in the model view separation principle, or the second rule we have, is to not add any rules, business logic or rules in the user interface. And this is something that you could easily do. For example, by doing the mistake of adding the rule if you win or lose. Inside the user interface instead. So by some kind of undisciplined coding or whatnot, I decided to, well, I just get the values from the dice and I check if they're 7, and if they're 7, we win. If they're not, we lose. And it should work, I hope, like it did before. That's a little bit weird. So it works like before. Oh, I won. But we have violated the principle. And unfortunately, this is not something that you would spot if you did a reverse engineering of the diagram. So this is something you need to be checking manually, more or less. Is the code that we add to the user interface something that actually belongs to the business rules or to the model? Possibly you can at least get a hint of it, because we use this get value and get value a lot. So maybe this hints that we should move this functionality into the model instead. So this is a big no-no, because it's the game rule. If we try to reuse the game and suddenly it won't work on our new platform because, well, the rule for if we win or lose is actually implemented in the user interface. And that's not a good thing. So watch out for that. Another mistake that you kind of like often make, if we take a look at this, this is not that nice. Get value dice 1, get value dice 2, and it's kind of like it's repeated, kind of like 2 lines between each other, and it's also, well, it's a little bit ugly to expose that, well, there are 2 dices in this way. And there are several ways you can treat this. But the wrong way would be to do this. Nicely enough, these 2 operations disappear, and instead we add a operation to get all the values as a string, because that is what we use here. I could just do this. MD1 get. Get values. Okay. Console. Yeah, it is. Yeah, yeah, you did. So let's do that instead. It's a little bit too early still. Too little. So at least we got it to compile, and we can run it, and it plays just the same. Printout is the same. User interface is the same. But we added actually some user interface code into the dice game class. Because what would happen if we would like to display, well, we don't want a space between the user think that the space between the dice values there, it's not nice. We should have a dash instead. So, okay, I know that's a user interface issue. I go look in the user interface code to find this, and you don't find it. And suddenly you need to change the business rules somewhere inside the business rules. But it's actually because of a user interface change request. And this is not a good thing. And this is also something that you cannot spot really by using a class diagram. So this is something you need to look out for. Is this return value, is it geared towards a certain type of user interface? If we would like to add a graphical user interface on this instead, then we would need to do some weird string parsing in the user interface to kind of like get the values from this string, and then do some parsing of that string to get the value of each separate dice, and then display this as a graphical object. Very, very strange. So adding these kinds of service functions, or I return this as a formatted list of something, is not a good idea. Formatting lists and stuff like that, well, it's part of the user interface and should be added to the user interface in that case. So doing stuff like this is often also not a good idea, because you have violated the principle. And this is also something that is very, very subtle and easy to do. Oh, it's so easy to add it into the model. Oh, I just return this as a formatted list of values using HTML or something like that. You kind of like just add the tags, HTML tags here in the model, because, well, then I don't need to return an array of objects or whatever it is. So that is also something that is a common mistake in when doing this principle. The next one is, of course, to just add user interface like stuff here, but that you often can spot in a diagram if you really are looking out. So I will just switch back to the good stuff. Something like this. And here we can see that we use system out and we use system in. So if we are really, really thorough in our application, we could add a system package. Out in, I'm not really sure if these are classes in Java actually, but something like this. And we have dependencies here. The console is dependent on that one and also on that one. And if we were to add print or statements directly in the dice game or in the dice, well, we would get these dependencies also. And that would, of course, not be a good thing, because we have kind of like violated the separation principle by going directly to the user interface API inside the model. But that is something that is often easier to actually catch, because you can either you can reverse engineer a diagram like this, or you can just search for keywords like in, out, system.in, system.out in these files. The other two problems that I mentioned, adding rules into the view and adding formatted output that is geared toward a specific user interface. Those two are a little bit more subtle and requires a little bit more discipline and time to inspect for. I think that this is it. Any questions? Everything is clear. So this is something that you need to do in your second workshop. You need to abide by the model view separation principle. And this means that you should only have dependencies from view inside to model. You should not have any dependencies from model to view or to something outside of the view that is basically user interface. If we were to be really thorough here, we have actually a dependency from dice to the math package. We use the random function there. So that is could be added if we wanted to. But then again, we also kind of like slip into the development view of the architecture, because then we are looking at more like at the APIs that are actually used by different parts of our systems. So as you can see, these views are not strictly separated. You can mix and match a little bit. Have some questions here in the chat. Yeah, there is some kind of at least the same domain between the two workshops. You don't need to follow your own domain model if you don't want to, but I suspect that you will have a member class in your domain model and a member class also in workshop 2 in the design model. So that is, well, not uncommon, so to speak. Possibly you will have both and registry also, and it could be a good idea. All right, any more questions? Good. I will be seeing you tomorrow, and I think we will be talking more about model view controller then. All right, bye for now.